the derivatives to analyze the function and the graph of the function. So maximum and minimum is still there. Let us review. You learn that for a function, if it has maximum or minimum, we can define the local ones, and also we can define the absolute or global ones. What we learned that we can use the derivatives to analyze the graph of the function to find the max or mean of a function. We have to follow these steps. In step 1, we start taking the derivative of the function. Take the derivative. Step 2, after taking the derivative of the function, set it equal to 0 or look for x values that make the derivative undefined. Set f prime equal to 0 and find x values that make the derivative undefined. Remember that we call these the critical values of the function. Critical value or critical values. You might end up with more than one critical value. In step 3, use a table. What is that table? That table includes critical values and the original function. Use a table to analyze y values. So in that table, you have your x values, the critical values, as the very first row, and your column has the function itself. Then you end up with some y values. You need to compare those y values and then decide if that y value is the maximum or the minimum of your function. Also note that if the domain of the function is restricted to an interval like a to b, then we need to include f of a and f of b in our table. Well, today we're going to talk about the second derivative test. How do we use the second derivative test to analyze the function and its graph? Very well. So these are the steps that we're going to take. Now, suppose I give you this function. Example. Consider f of x equals to x squared. The question says, well, analyze the maximum and minimum of this function. If we follow the steps, in step 1, we take the derivative of the function, f prime, which is 2x. In step 2, we find the critical values by setting the derivative equal to 0 and look for x values that make the derivative undefined. Luckily for us, this derivative is a linear expression. It's defined everywhere. So it's not undefined. We have to just set the derivative equal to 0 and solve for x. 2x is equal to 0. It means that x is 0. X equal to 0 is a critical value. In step 3, we're going to form a table. This table has critical value 0. We're going to find the y value at 0 and then analyze the function. F of x is equal to x squared. If I plug in 0, I get 0 squared, or just 0. Well, some points, some values before 0, some values on the right-hand side of 0. So suppose you plug in -1 and then plug in 1 into the function. If I plug in -1 into the function, I get -1 squared, which is just 1. If I plug in 1 into the function, I get 1 squared, which is 1. So between 1, 0, and 1, 0 is the minimum number. What's the meaning of that? It means that my graph decreases and then it starts increasing. Remember the graph of this function. The graph behaves like this. This is just a parabola. We already know how to graph this parabola. The function, this is the graph of the function, start decreasing. Remember, we read graphs from left to right. It starts decreasing. It reaches to its minimum value, which is 0, and then it starts increasing. What's the meaning of that? It means that the derivative of function is negative before 0, and the derivative of function is positive after 0. Well, it means that if you think about your tangent line is a decreasing line. F prime is negative. The tangent line has negative slope, and on the right-hand side, the tangent line has positive slope. Well, now I have a question for you. What if I take the second derivative of this function? Question. We learn how to take different derivatives. What if we take the second derivative? What does it tell me? If I take the second derivative of the function, well, the first derivative is 2x, the second derivative is just 2. The second derivative of the function is just 2, which is a positive number. Positive number. What does it tell me? If you take the second derivative of the function and it's a positive value, then for sure you have a minimum for that function. It means that your graph concave up. It opens up. Definitely you get a minimum value. Positive number. It means that we have a minimum value. Well, now take a look at this example. Keep these examples in mind. So whenever you try to analyze different functions, you have some reference to remember about these examples. So another example. I'm going to give you this example. F of x is equal to negative x squared. Another quadratic function. Step 1, take the derivative. F prime of x is minus 2x. Step 2, you take the derivative and set it equals to 0. It's defined everywhere, so we're not actually worried. Negative x is equal to 0, or just x is equal to 0. This is my critical value. Step 3, form your table. In your table, you're going to have your critical value, x equal to 0, and then you have your function, f of x equals to negative x squared. You're going to find the y value at 0. Well, if I plug in 0 here, negative 0 squared is just 0. We need some values on the left and on the right of the value, critical value, like -1 and 1. If I plug in -1 into this function, I get -1 squared, -1, or just -1. I get a smaller value. If I plug in 1 into the function, I get -1 squared, which is again -1. What does it tell me? It tells me, hey, my graph starts increasing toward 0, and then it starts decreasing toward 1. What's the graph like? The graph is like this. This is the graph of this quadratic function. This is the parabola that you have. We read graphs from left to right. From left, you start increasing. You reach to the maximum value and you start decreasing. It means that the derivative of the function, which is the slope of tangent line, on the left is positive, and the slope of tangent line on the right is negative. And again, the question, what if we take the second derivative of this function? The second derivative of this function is equal to -2, a negative number. So whenever you take the second derivative of the function and it is a negative number, it means that for sure your function has a maximum. It concaves down. So we have, it means that we have a maximum, as you can see. Very well. Now we're going to talk about inflection point. Let me find a good example for you. So inflection point is the point that the function changes concavity. Inflection point is the point where the function changes concavity. Well, the graph might look like this. Concave down, then concave up. In this case, well, your second derivative is negative, and here your second derivative is positive. Concave down, then concave up. This point that your graph changes concavity is called the inflection point. Or it might concave up, then concave down, concave up, then concave down. Well, in this case, your second derivative is positive. Here, your second derivative is negative. Well, the point that the graph changes concavity is called the inflection point. To find the inflection point, you need to set the second derivative of the function equal to 0. Sometimes you have cases that the second derivative does not exist, but your graph changes concavity. Very well. Let's take a look at one example.